Welcome to a short video on array lists and what they're useful for. So array lists are just implemented for the usage of arrays. We're going to use an array that's going to be the underlying data structure for our list. The cool thing is we're going to keep track of the number of contents in an array, and what we're going to do is we're going to double the size of our array if the count of our contents ever happens to be equal to the length of the array, because at that point it knows that we're going to deal with an invalid boundary on an array. So what we need to do is we need to copy over the elements into a new array, which is going to be double the size. So let's talk about just a couple of methods here. So the first method is the addition method. So in the average case, what we're going to do for adding our elements to our array is, by default, we're going to add the elements to the very end of our array. This is the best case scenario because when we insert the item to the end of our list, it's going to be constant because it doesn't require any shifts. If we happen to add an element to the very front of our list, what we're going to end up doing is we're going to have to shift all of the elements in our array over to the right. And here's a little important note. When we add an item, the index of the item must be within the constraint of the size of our current list and not our array. Remember, our array is going to most likely be greater than the actual size of our list for the most part. We can ensure that the size of our list is always equal to the size of our array by using a trim to size method on our array, which basically states that what we're going to do is we're going to create a new array, which its size is going to be equal to the number of items that we have in our current array, and then just copy over the data elements there. So let's actually take a look at what an addition looks like. So we're going to assume that we've added 3, 4, and 1 here, and then what we do is, for our next case, we decide to add, let's say, the item 5 at index 1. So what that's going to do is that's going to insert an item right at this spot here, which is index number 4. And in order to do that, we could just take this 4 and delete it, but then it would be a special kind of add method. Remember, an add method is just adding another element to our collection here, without actually deleting any of the other elements that are currently there. So what we need to do is we need to move this 4 over to this spot and the 1 over to this spot, and then add the 5 here, so that our array looks something like this: 5, 4, and 1. So as you guys could probably see from this visualization, if we have a list that contains, let's say that its size happens to be like 1 billion elements. If we add something to the very front here, it can be very expensive having to traverse through 1 billion plus, or 1 billion elements worth of shifting. So in that case, it's not optimal. So just to reiterate, adding an item to the front of our list happens to be the worst case scenario. Now, what we're going to do now is I'm going to start a new array and deal with the removal method. So in the worst case scenario for a removal method is that we happen to remove the first item. The problem with this is, let's say that we have 5, 4, 6, and 1. If we happen to remove this item here, what we want to do is we want to shift these items over to the left so that we can do some valid indexing through our array, because what ends up happening is if we make a call to something that says like get first, I'm going to say get f, and get f is always going to return the first item. What it's going to do is, depending on our implementation, it would try to return this 0th index, which would have a no longer valid data entry here. So that's why what we need to do is we need to shift the elements over. We could get a little bit smart in terms of saying, okay, let's just move our front of our list over to the next index in our array. Now in that case, that would be pretty inefficient in terms of size as far as things go, and it would just kind of screw up all of our methods for ensuring capacity or doubling the size. Because doubling the size, it just literally copies over the indices um, of the old array into a new array. So, yeah, so the worst case scenario is that we remove the first item and we have to shift everything over to the left. Once again, with a billion items in our list and we remove the first item, it requires a shift of a billion elements. Best case is that we don't have to do any shifts at all, and that happens when we're actually removing the last item in our list. And the item must be in the list in order to be removed. We're going to find later that we're going to have some sorting methods that actually can improve the removal and the addition runtimes that we currently have. So, alright, let's take a look to see the implementation. So, as you guys can see here, I've just created a driver class. And in this driver class, it asks the user some various questions as to what sort of list that we'd like to deal with. I've only actually implemented the array list for now, and it only gives you 4 functionalities, which happen to be add, get, remove, and size the list. The reason for that is those are going to be the basics that people are most likely going to use. The rest of the methods that I have are going to be private, and I don't want my client to access them because they could abuse ensure capacity or trim to size and a lot of different things there. So I use a couple of try and catch methods. I use the try and catch just to make sure that the user is giving me a valid number. If they're not giving me a valid number, then I do some default here. I don't actually print a stack trace because I want my program to still keep running here without terminating or breaking. So basically, I just ask them for basic information in terms of what they want to do. So let's actually take a look at the addition method here. So over here, I have my basic addition method that takes in the item that we want to add, and it makes a call to its special enhanced method, which is going to be the add method with 2 more parameters over here. So what we do is we first make sure that we can actually add the item at the appropriate index. If we can't add the item, we just return because we don't want to pursue the functionality of this program any further. Otherwise, what we do is we know that we can add an item, so we increase our content size. Then we check to see if the content size is within the boundaries of our array. If it's not, we call this method called double size. So what double size is going to do is double size is going to change the size of the array by, well, the original length times 2. As you guys can see over here, we create a new array that's going to be double the size of our previous array, and then we just copy the elements over. So moving onward from there, what we want to do is, for our addition method, we're going to assume that we're given some generic index, and what we want to do is start from the very last item in our list and shift the elements over to the right. The way we do that is we say my array at index I is equal to my array at the previous index. And then what we do here is we say, okay, now that we've appropriately shifted our elements over to the right, what we can do now is we can grab the array at the specific index and then just plop our item in there. So that's not too bad as far as things go. Get item is pretty basic. As long as the index happens to be less than our content size, then we know that we're dealing with a valid boundary, so we can just return my array at index. If this doesn't happen, then we'd return -1. It's entirely possible that they could add -1 to our list, but we're gonna hope that they don't add that. In another case, what we could do is we could return integer.max integer or integer.minimum integer minimum value, so that it's most unlikely for them to actually get a return value that's something in their list. Okay, so now what we're doing here is in our remove method, it's a boolean. It just basically returns as to whether or not we were successful with our removal. What we originally do is we set the removal location to be -1. Why -1? Well, -1 is not a valid index in an array. So basically what we're going to do is this little for loop here is just checking to see if there's a valid removal location. If there is, we update it. And we break. If it's not there, we return false. Special note about this removal location here, it only finds the first index of the item. So it doesn't find all the other indices. Over here, down here, this is where we do the appropriate shift to the left of all of our elements. And the way we do that is we say, okay, we're going to start from our current removal location, and we're going to keep going up until we get to the last item in our list. And what we're going to do is we're going to say the item that we're currently at is going to be equal to the item to the right of it. Basically what this is doing is this is shifting the right element to our current element over into our current element. And then what we do is we decrement the size to make sure that we're not keeping the size of our array too large as far as things go. What we could actually do here is we could do something like this, where we replace the item at the, I believe we could say, not at the removal location, we could say the item at the current size plus 1. No, the current size is good. So we could say the item at the current size is equal to integer dot min value, and this would basically just replace that item with a number that shouldn't be anything that they'd expect in their array. But we're just going to use lazy deletion here, where we actually don't remove the last item, we just shrink the size of our array. And then eventually the add method will replace that value over time. For our toString method here, it's nothing more than just a simple string builder that follows the postfix traversal. It basically says as long as our constant size is not equal to 0, we're going to keep adding our numbers to our list or to our string, and then eventually what we're going to do is we're going to return the string version of our string builder. The reason why I use this string builder here is because if we have a whole bunch of content in our array, it can be costly to just use a string over and over again, because once again a string is an object, and every time we do something like string plus equals this, something like this, what it does is it basically just returns a new string and sets the string to be equal to that new string. And it's just adding a whole bunch of objects over and over again. Whereas opposed to this, the string builder is just one object continually, and it's nice because it just keeps appending one thing at a time to our actual object here. Okay. So now that we've gone over a brief overview of what this class is doing, let's actually run the program and let's see what happens. So in this case, I've run it a few times myself. So we're going to compile it, and then we're going to run it. So we don't have a linked list yet, so we're going to deal with an array list. Spelled array list wrong. So now that we have prompted or given the input answer of array list, it prompts us with the size. So in this case, the general default capacity happens to be a size of 10, which is good, but I'm going to say that my default capacity is going to be the size 2. So, alright, so it asks us a plethora of options here. So we have add, get, remove, and size. So what I'm going to do is I'm just going to type in size, and it'll tell me that there's 0 items in the list. And then what it does is it prints out the contents in the array right after that. So I'm going to add an item. I'm going to add 4, and I'm going to add just a string here. And you guys are going to see that what happens in our try method, or in our try block here, not our try method, in our try block, it tries to see as to whether or not this whole thing can be parsed to an integer. If it can't, it falls into the exception down here, or the catch, and it just says that we're going to automatically add the item to the end of the list. And then, as you see, the toString updates. So let's actually check to see if size is working. So size seems to be working here. So let's add a couple of more items here. We're going to add 5. What we're going to do is we're going to add 1. We'll just keep appending them to the end. Then we're going to add another one. 1 is going to be added to index 1. So now we have 4, 1, 5, 1. Okay, so now what we're going to do is we're going to call the get method. The get method is going to ask us for an index. We're going to say index 5. So yeah, it should return -1 because there is no index 5 in our array list. So the next thing we're going to do is we're going to deal with the removal, and we're going to see what happens when we remove 1 here. So I'm going to say the item to be removed is 1, and what it tells me is it says, okay, if I found the number here, then I can successfully remove it, and then I just perform that removal. So let's add a remove on an item that doesn't exist in our list, and it says, sorry, but that's not an item that I recognize. In this case, what I could do is I could let the user know that I'm very, very upset about this by having an angry frowny face. But anyways, that was just a little bit of an introduction to the array list, a little bit of its implementation here. Bottom line is array list is very nice. Underlying structure is an array. It follows the basic principles of the list interface. I decided not to use something like implements list because the thing is, the Java already has its own implementation of array list, and it's by far a lot better than this one over here. This one over here is just kind of a simple and quick implementation, but it's definitely an implementation that's good to practice in case you ever have to write your own array list class in the future. So, once again, I hope you guys found this video useful, and we'll see you guys next time.